Welcome to Cloud on Air, live webinars from Google Cloud. We're hosting webinars daily. You're watching Cloud 101, where speakers discuss the fundamental concepts of Google Cloud Platform and learn from the best practices in different markets. My name is Philip Meyer, and today we'll be talking about architecting with Google Compute Engine, building your cloud infrastructure. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. Let's get started. So in this webinar, I will tell you about our updated Architecting with Google Compute Engine course and demonstrate some of the infrastructure services that you will get to explore in that course. If you stick around until the end, we'll give you a special course offer and wrap up by answering some of your questions. Let's start by talking about why you should learn about Google Cloud and specifically Compute Engine. Consider for a second the impact Google search has on our daily lives with timely and relevant responses. Now, think of other Google products like Gmail, Drive, YouTube, Photos, Chrome, Play, Maps, and Android. Each of these products has over 1 billion monthly users. Now, Google had to develop technologies to meet the requirements of a distributed computing infrastructure that can support those billions of users. Google Cloud's goal is to share these innovations and infrastructure with you so that you can also impact and delight your users. This map represents GCP's global infrastructure. On a high level, GCP consists of regions, which are the icons in blue, points of presence, or POPs, which are the dots in gray, and a global private network, which is represented by the blue lines. GCP's well-provisioned global network connects over 60 zones to over 130 points of presence through a global network of fiber optic cables. Google is continuously investing in this network with new regions, points of presence, and subsea cable investments. In other words, from an infrastructure perspective, GCP is a set of data centers and an extensive fiber network. But there's more to GCP than its infrastructure. On top of this infrastructure, GCP uses state-of-the-art software-defined networking and distributed systems technologies to host and deliver your services around the world. These technologies are represented by a suite of cloud-based products and services that is continuously expanding. Many of the products and services are represented by unique blue hexagonal logos, such as the one shown here. Now, it's important to understand that there's usually more than one solution for a task or application in GCP. For example, GCP offers a range of compute services. The service that you might be most familiar with is Compute Engine, which lets you run virtual machines on demand in the cloud. It's Google's Cloud's infrastructure as a service solution, and it provides maximum flexibility for people who prefer to manage server instances themselves. Google Kubernetes Engine lets you run containerized applications on a cloud environment that Google manages for you, under your administrative control. Think of containerization as a way to package code that's designed to be highly portable and to use resources very efficiently. And think of Kubernetes as a way to orchestrate code in containers. You can learn a lot more about Google Kubernetes Engine in the Architecting with Google Kubernetes Engine course. App Engine is GCP's fully managed platform as a service framework. That means it's a way to run code in the cloud without having to worry about infrastructure. You just focus on your code and let Google deal with all the provisioning and resource management. Cloud Functions is a completely serverless execution environment, or functions as a service. It executes your code in response to events, whether those events occur once a day or many times per second. Google scales resources as required, but you only pay for the service while your code runs. You can learn a lot more about App Engine Cloud Functions in the Developing Applications with Google Cloud Platform course. Now, this specialization focuses on Compute Engine as the computing platform, which is why we renamed it to Architecting with Google Compute Engine. As part of this refresh, we made significant changes to the labs, quizzes, demos, and slides, and have re-recorded all of the content of the courses that I've listed here. That is the Essential Cloud Infrastructure Foundation course, the Essential Cloud Infrastructure Core Services course, and the Elastic Cloud Infrastructure Scaling and Automation course. Let me actually head over to Coursera to show you this updated specialization. So here is the specialization page on Coursera. And if we scroll down, we can go to the courses section. And we'll see that this specialization actually consists of 5 courses in total. The first course on here is the Google Cloud Platform Fundamentals Core Infrastructure course. And this is essentially the prerequisite. And if you already have equivalent knowledge, you can actually go ahead and skip that course. If I scroll further, we see courses 2, 3, and 4 are the courses that we updated. And there's also a 5th course, the Reliable Cloud Infrastructure Design and Process course. We'll talk about that a little bit more later. But for now, let's take a closer look at each of these 3 updated courses. So first, the Essential Cloud Infrastructure Foundation course. Here you'll use the GCP console and Cloud Shell to implement VPC networks, firewall rules, and virtual machines. For example, you will create different types of VPC networks with firewall rules and VM instances as shown in this diagram. This is actually one of the network diagrams that you will configure in a lab of the course, and then you will explore the connectivity across those networks. So let me talk a little bit more about this. We have 3 networks here. There is the My Network network, which is an auto-mode network. An auto-mode network just means that there is a subnet in each of Google's regions. And then we also have 2 custom nets. We have management net and private net. And these are custom in that I define the different subnets in each of the regions. And we can also see that we have 4 virtual machine instances across these networks. So let me actually show you how these configured networks, firewall rules, and instances look like in the GCP console, and then we're going to explore the connectivity. So I've already created this network here for you. Now, every new network, or I should say every new project that you create in GCP will, by default, have a default network. This is also, as you can see, of type auto. That means, again, that there is a subnet in each of the regions that we have. And if I scroll down, we can see the custom net management net that we've created, which is in US Central 1. And all I did is I just define an IP address range and give it a name. Then we have another auto network called My Network. And if I scroll down further, we have another custom net called Private Net. And there we have 2 subnets across 2 different regions. Now I can also look at the firewall rules if I click over here. And I've sorted these already by network. The default network comes by default with some firewall rules as well. And I created firewall rules for My Network, Private Net, and Management Subnet. And if we look at the protocols and ports, we can see that I'm essentially allowing ingress traffic for ICMP, as well as TCP 2280 and 3389. So essentially, I'm allowing traffic for ICMP, HTTP, SSH, and RDP. And this is for ingress. By default, egress is allowed, so I don't have any egress rules that I need to define. Now, I've also created some compute engine instances, and I can look at those here. So here we can see 4 instances that are created. And I've put in a column here so we can see the different networks that these instances are on. So 2 of them are on the My Network network, and the other 2 are on Management Net and Private Net. Now, from a zone perspective, 3 of these instances are actually all in the same zone, which is US Central 1A. And there's another one here which is in the same network as one in US Central 1A, but in a completely different region. So what I want to show now is the connectivity in between these. And what I'm going to do is I'm just going to grab the internal IP address of this first instance here, and I'm going to SSH to the other instance that is, again, on the same network, My Network, but in a completely different geographical location. To be exact, in a completely different continent. So let's just wait for the SSH connection to be established. And then we're just going to use simple ping to ping that instance. And let me just make this a little bigger and get some real estate. And then we're going to ping. I'll pass the IP address, and let's just do this 5 times. And we can see that this succeeds, and it gives you some metrics too about the latency that we have here. So very straightforward. I have a global network. That's what VPC networks are. These instances are in different regions, in different zones even. And with that, I can still, though, ping them on the internal IP address because they are on the same network. Now, let me grab an IP address from another instance. Let's actually take the instance above, the management subnet US VM. And I can read the IP address off right there. and try to ping that internal address. And when I do that, you see that none of these pings are coming back. So even though both of these instances are both in US Central 1A, the one I'm making this request from and the one that I'm trying to access, the fact that they are in different networks means that they're isolated from one another. Now, I can still ping, obviously, the external IP address. So let me move this over here and grab the external IP address, and we can show that that still works. But if you wanted internal connectivity, you would have to set up other mechanisms such as VPC network peering, or a VPN, or even create a virtual machine that has multiple network interfaces. So let me just put in that IP address, 35.192.98 and 203. And let's try to ping that. And we can see that works. So the routes obviously are established to external networks, to the internet essentially. And I do have firewall rules that allow this communication. So I can go ahead and close this, and we can head back to the slide. So again, this was just a demonstration of what you're going to be able to do in this course. So now let's move on to the next course that we've updated. The next course is the Essential Cloud Infrastructure Core Services course. And here you administer identity and access management for resources, implement data storage services in GCP, manage and examine billing data of GCP resources, and monitor resources using Stackdriver services. For example, you'll create a custom dashboard like the one shown here with Stackdriver monitoring. These dashboards contain charts of the metrics that you want to monitor, like your instances' CPU utilization, the packets or bytes sent and received by those instances, or maybe even the packets or bytes dropped by the firewall rule of those instances. So let me actually show you what these dashboards look like and what else you can configure with Stackdriver monitoring. So I'm going to head back to my demo. And I have another project already here set up with 3 different instances. And I've exchanged some traffic in between those instances to both put a spike on the CPU usage as well as to show some network traffic. Now, we'll head into Stackdriver in just a second, but if I just even click on one of these instances and show the info panel, we'll see that we can already get metrics and actually dashboards on these instances straight from the GCP console. And let me minimize this here on the left to give it a little bit more real estate. And I can actually click on multiple instances at the same time. And over here, I have my CPU usage. And I can scroll further down. I have the networks and bytes, and the packets, and even disk I/O. So I already, within GCP, have access to dashboards, and I can even change the time frame, the window that we're looking at here. Now, you might look at this and say, hold on, what's going on here with the CPU usage? It's somehow above 100%. If you look at the type of machine, it says one virtual CPU, but if we actually click into one, it'll tell us that this is of type F1 micro. And these instances actually have burst capability. So for a specific amount of time, they can actually run above their rated CPU. And that's exactly what's happening right here. Now, that's probably not the best design. We probably want to have a dashboard that alerts us if we go above 100%. And that's what we're going to explore now within Stackdriver. So let me head over into Stackdriver. I've already created what is called a workspace. And this essentially ties one or multiple projects to Stackdriver so that I can monitor resources. Now, one of the first things you probably want to do is create a dashboard. So I can just go to Dashboards and click Create Dashboard. And I can go in here and then add charts. Now, I'm interested in my VM instance, so I can just type that in here, GCE VM. There we go. GCE stands for Google Compute Engine. And then I can select a metric. Now, this might be rather complicated. And one nice trick is to actually come back to the page we were on earlier. And if we're, let's say, interested in the CPU usage, we can go in here and we can look at these different filters. And let's see if I can get that from earlier. I got this working just earlier. I think my screen is a little small. But from here, you can actually grab the, here, if I click on CPU, you can actually grab the name of the API that we're interested in. I'm unable to do it right now. So let's just go back and grab it from here instead. I'm going to type in CPU utilization. And now I want to scroll down. I'm interested in compute. So let me look for that. You can see we can also monitor AWS EC2 instances. Oops, I went a little too far. There's App Engine, machine learning. Here we go. Great. So there we can see the CPU utilization. It's in a different time window. So let's go back to 6 hours. It's kind of what we saw earlier. So I have all my instances. I could add some filters. I could group this. I could aggregate this. I could do all sorts of things. And let me show you something, a dashboard that I already created instead of creating all these charts right now. So here I essentially try to replicate what we have in the GCP console. So I have CPU utilization, the received bytes, some disk I/O, and also some network traffic. So you can easily recreate this in here, and you can share this dashboard. You can change the time frame. You can put all sorts of filters in here. Cool. So next, what I want to show you is we can also from here directly create some alerts. So if I click on alerts and click create a policy, what I can do is I can now say, let's add a condition on that CPU utilization again. And we're going to say that if the CPU utilization is above 100% for some certain time frame, we want to send out an alert because maybe that's not designed that way. Maybe someone needs to take action if that happens. So let me, again, pull up the CPU utilization. And scroll down. And here it is. And so that we have it again. Looks just like a chart. But now when I scroll down, we also have the configuration. We have triggers. So anytime I want to now say that this is above 100%, there's a threshold I'm going to set. I want some certain action to happen. I could add more conditions now, but more importantly, I probably want to specify that something happens, like maybe an email is sent. I'll put in an email address, and then I can also add some documentation. Well, if anyone gets this email, they need to know what to do with it, right? So if the CPU utilization is above 100%, I want to clearly specify what the receiver of this email is supposed to do when they get that. So I can put that in, I can even preview it, and then I can give it a name so that I can have multiple policies. Now, another interesting feature of Stackdriver monitoring are uptime checks. And I've already configured these. And essentially, I have these 3 instances that I created earlier, right? And what we have here are we have different worldwide locations. Some of them are in the US. We have one in Europe, in APAC, and in South America. What we're essentially doing is we're pinging, or I should say we're accessing these on HTTP to ensure that these are up and running around the world, that nothing is preventing them from receiving traffic. Maybe I'm blocking a firewall rule from a specific IP address range, or there is, maybe the service is down, maybe there's some network connectivity issues across the world. So that's what this chart is really useful for. And I can actually, when I create these, I can directly create alerts on them. And when I explore one of these, I can get some more information on both the latency, which is really useful. So obviously, the checkpoints that are furthest away from these instances, I'm going to have the lowest latency. So these instances are, I think, located in US Central, which is in Iowa. And we can actually see that the Iowa checkpoint here has the smallest latency of just 2 milliseconds, whereas someone who's trying to access the service from, let's say, Singapore takes close to 400 milliseconds. And we can see a chart here, and we can get an idea if this latency changes. And we even have some uptime checks in here. And I can just get a lot more information about all of these regions directly from here. Now, the best part is you're going to be able to configure all of these charts, alert, and uptime checks in the lab of this course. So let's actually then head on to the next course. And in the Essential Cloud Infrastructure Scaling and Automation course, you will learn about services that enable you to connect your infrastructure to GCP. You'll also configure load balancers and autoscaling for VM instances, automate the deployment of GCP infrastructure services, and leverage managed services. For example, you'll create 2 different managed instance groups in 2 regions that serve as backends in different regions, as I mentioned. Specifically, as we can see here, we have US Central 1 and Europe West 1. And then what you're going to do is you're going to create an HTTP load balancer, and you're going to stress test that and see that the load is actually distributed globally and that these instances on the back will actually scale. So you'll start off by just having 1 instance, but this one instance is going to be part of what's called a managed instance group. And that allows it to scale depending on specific conditions that you specify so that new instances can be spun up. This is essentially where the elasticity is in cloud. All right, so let's assume you have a shopping application and you just run a huge ad on a new product that you're selling, and all of a sudden everyone heads to your server and wants to buy that. Well, you now have a lot more traffic than you might have anticipated, and rather than spinning up 10 instances already, you just start with a few and allow them to be scaled automatically. And that's, again, exactly what you're going to perform in this lab. And I've actually kind of pre-built this for you. So let's take a look at that. I just got to start it up. So I'm putting a load now on a load balancer. So let's take a look at that. So this is exactly, again, the diagram that we have in here. I have instances in US Central 1, and I also have instances in Europe West 1. And what I'm going to do is I have another VM that is stress testing these, and it's located in in US West. Now, by default, traffic will be forwarded to the backend instances that are closest. So if I'm thinking US West, then US Central is definitely closer than Europe West. So that is how the traffic is going to be distributed. Now, the backend instances are going to scale because I'm really stress testing this. And once a specific backend can't handle the traffic anymore, the traffic is going to be load balanced to the other backend as well. So the Europe West 1 backend should also be seeing some traffic once that happens. So let me show you that setup in the GCP console, and then we'll try to see if we can actually see that auto-scaling load balancing happening. So here we go, and what I've done is I've created an instance template in Compute Engine, and what essentially this is just instructions for creating VM instances. So what I've specified here is the type, the name, the disk, and then what I do from there is I create instance groups. And I have 2 instance groups, and you can see some of these are going through some scaling right now, but I have 2 instance groups, one in Europe West 1 and one in US Central 1. And these are allowed to scale up to 5 instances. Now, they're both using slightly different auto-scaling mechanisms, and we'll see those in a second. And if I go to my VM instances page, I can also see that I have all my instances here. And I've already been stress testing this, so we see that a lot of instances are spinning up here. But again, here's my stress test instance in US West 1C. And we can see we have instances in Europe and US Central 1. Now, that is essentially the backend. Let's talk about the load balancer. So what I've done is I've configured a load balancer here. It's an HTTP load balancer, which is a global load balancer. The great thing is it provides me one IP address globally, and I can just send messages to that IP or request, and that will just be balanced across all of the backends. So if I click on that, we can see more about this. We can see I've actually configured both an IPv4 as well as an IPv6 address. And we can see the different backends we have. So I have Europe West 1, and I have US Central 1. Now, I can get more information by clicking on backends. And you're going to do this in the lab. And click on the backend itself. And here we can see I've got this enormous traffic coming from North America. I'm really stress testing this. So even though this is coming from US West, only some of it is going to US Central 1. And actually, a lot of it is going to Europe West 1. That's by design. What I've done here is I've told this backend that it can only handle a very small number of requests per second, so that I can show you specifically that when the traffic is very large, it will spill over to different regions. I can get more information here around the CPU utilization, the rates. I'm stress testing this so much, and the backend instances are so tiny that I'm getting even some errors around this. Again, this is just for demonstration purposes. You wouldn't have a backend that is this small in terms of an F1 micro here. You would have more powerful backend instances, and you would allow them to be scaled even more. In my case, I limited this at 5. And again, with the stress test that I'm creating here, I'm exhausting my backends already. But this is purely a demonstration that I'm just trying to show you. All right. So again, you will get to implement this load balancer in a lab of the course, and you will stress test this to observe the global load balancing and the auto-scaling. So let me go back to the slides. And that brings us to the course offer that I mentioned. So let me talk about the course offer. So here is a link. This is the link you want to go to. There's also a QR code. And what's going to happen is you're going to come to the Google Cloud Specializations page, specifically the promo landing page. On there, you can choose between all the different specializations that we have that are part of this promo. And obviously, the architecting with Google Compute Engine specialization is part of that. You will then have to complete the checkout. Now, a credit card is required, but you will not be charged for the first month. And the subscription can be canceled at any time. There's also a fine print here in terms of the promotion. So 100% off your first free month. And this is only valid until December 31st and while supply lasts. So that's it for the presentation portion of the talk. So please stay tuned for frequently asked questions. We'll be back shortly. So these seem to be some of the top frequently asked questions. The first one is, what should I already know before I begin architecting with Google Compute Engine? Great question. So I showed you the specialization earlier, and in there is the prerequisite course, the GCP Fundamentals Core Infrastructure course. So that is really what we expect you in terms of prerequisites. Otherwise, it's also really good to have some working knowledge of Linux, because you're going to be using virtual machines quite a lot, and we mostly create Linux-based ones, and you're going to be using the command line. So just some basic proficiency in that is really going to set you up for success to work through these. Now, the next question we got is, what is the duration of the training? So again, that prerequisite course that I just mentioned takes about 10 hours to complete. Then the 3 updated courses that I mentioned in this webinar take about, I think, 22 hours to complete. And then the last course, the design and process course, takes about 16 hours to complete. And now you can take this over several weeks. Obviously, if you want to do it within your Coursera promotion, you want to finish it all within months. But you can space the learning out yourself. So you could do it quicker or faster depending on what your schedule and interest allows for. All right, so the next question we have is, how does this specialization relate to the Associate Cloud Engineer and Professional Cloud Architect certifications? That's a great question. This specialization is actually part of the learning path for both of those certifications that we have. And you know what, let me actually just go quickly over to our website, our external website. You can still see the load balancer working here. And if you go to our external website on training, which is cloud.google.com/training, there is a certification area. And if we go click on that, you can see that we have all the different certifications listed on there. We have the Associate Cloud Engineer and the Professional Cloud Architect. And I mentioned that both of these certifications, or I should say this training that we just talked about, is part of the learning path for both of these. So if I scroll down, you can see that first step is to review the exam guide, and the second is the training. And here it is for the Professional Cloud Architect, and similarly for the Associate Cloud Engineer exam. We can see it here as well. Now, it's important to note that you want to do more than just take these trainings. There's also a specific course on preparing. There's an official cloud study book. We really recommend hands-on practice. So these are all specific self-paced labs or quests within Quick Labs. And then we even have a practice exam. So really take your time, figure out your learning strategy. Don't just take the course and then take the certification right after, but figure out where are your gaps from the exam guide, fill those gaps with the training, and then figure out where you need to have more practice to have more comfort to be ready to take the exam. And best of all, good luck with that. All right, so let me go back to the questions. The other question was, how does this training relate to the architecting with Google Cloud Platform specialization? That's another great question. This training, the architecting with Google Compute Engine training that I talked about here, used to be called the architecting with Google Cloud Platform specialization. Now, what we've changed is we've focused the specialization on Compute Engine. That is because we also now have a specialization focused on Google Kubernetes Engine. And with that, we've removed some content, but we've also gone deeper into Compute Engine and updated all of the 3 courses that I just mentioned. So that's, we've re-recorded all the videos, we've all new labs, and we've all new slides. Now, that being said, if you've already taken the architecting with Google Cloud Platform specialization, you might not get too much more value out of taking this new specialization. But if you use the 1-month free Coursera access, you can go ahead and just try it out, and you'll be the judge of that. All right, so the last question that I have here is, does Google Cloud offer training courses for other job roles? And yes, it does. And for that, let me actually go back to the training site that I was just on. So I went to the specialization, and I'm just going to go back. And we can see here that we actually have role-based learning path. Now, the architecting with Google Compute Engine specialization is part of our cloud infrastructure learning path. And you can see that here we are targeting IT professionals who are responsible for implementing, deploying, migrating, and maintaining applications. I earlier mentioned a course for Cloud Functions and App Engine that is under application development. So this is really targeted for application programmers and software engineers who develop software programs in the cloud. And so if you go in here, you can learn more about each of the individual tracks we have. So we have a Cloud Platform Architect track, which is where this specialization is in. We have networking tracks, security tracks, and many more. So to answer your question in short, yes, we do have a lot more training for different job roles. Okay, and that brings us to the end. Thank you for tuning in. Please visit Cloud OnAir for more content from Google Cloud experts.